Hello friends, once again welcome you all. We are discussing important questions of chapter number 3, Kinetic Theory of Gases and Radiations. See, in this chapter, first assumption rather, there are certain assumptions regarding kinetic theory of gases. Those assumptions are very important as far as theory part is concerned. Theory question will be there on the assumptions. Second important part, second question, expression for the pressure by using kinetic theory of gas. And then small definition or there will be a small question for 1 mark on mean square velocity or mean free path. Okay, the next is very important. See, here Boyle's law, which is actually based on the expression of pressure. So I feel derivation for Boyle's law will be there for 2 marks, and different expressions for kinetic energy. We know that there are certain expressions like kinetic energy per molecule, total kinetic energy per unit mass, kinetic energy per unit volume. See, instead of doing all these theoretical derivations, you prefer to solve one particular numerical, which I have already taken in the numericals while we were doing practice of numericals in the classroom. Okay, so that numerical will revise the whole that important part of kinetic energy. Okay, now instead of doing degree of freedom for monoatomic, diatomic and polyatomic gases, just go through ratio of specific heat. Okay, that is very important. Ratio of specific heat for mono, di and poly. And there is one important point what I would like to suggest you people. The next is what study of perfectly black body. Ferry's perfectly black body. Construction will be there. And my favorite part, Wien's law. Wien's law is very easy, but it is important for 1 mark question to find the temperature of distant planets and all. So that part is important for 1 mark numerical or 1 mark MCQ. Next important part of this chapter is what? Stephen's law or rate of loss of heat. It is very critical, students. Why it is critical? Because see, if a body is perfectly black, then the loss of energy is different, and for ordinary body it is different. So I feel there will be a numerical based on particularly for perfectly black body and for ordinary black body. Especially in case of numericals, what I feel, there are certain questions in the book bank questions of HSC board, like velocity, RMS velocity of oxygen is root 2 times RMS velocity of sulfur dioxide. Show that kind of questions. Such kind of what we can say, these are what numericals, but approach is theoretical, where we need the concept of RMS velocity. Okay, then the important numerical I have already gone through is what? Kinetic energy, different kind of kinetic energy. Then we can say the important point is what? The numerical on loss of energy for calculate the energy radiated in 1 minute by perfectly black body. The area of that perfectly black body is given as like 100 square centimeter or 200 square centimeter with the value of Stephen's constant, like sigma is 5.67 into 10 raised to minus 8 in SI unit. By using this data, we can calculate the amount of heat radiated by that body. Okay, then to confuse the student, the numerical, instead of using word, find the amount of energy loss, they can use the word the power radiated, and we know that Q, amount of heat per unit time, is what power. Okay, so please try to understand this googly in the numerical. That's all for this chapter. Thank you very much.